I'm Bryon Clipp, and I'm here to present our work, MEVID, Multi-View Extended Videos Without Identities for Video Person Re-Identification. Real-world person re-ID is challenging due to multiple viewpoints, varying appearance, such as changes in clothing, human pose variations, lighting changes, occlusions, resolution changes, differing backgrounds, and high levels of crowd density. Academic datasets to date fail to fully represent these challenges. MEVID fills in this gap. Our dataset includes 158 unique persons in 598 outfits, tracked in over 8,000 tracks from 33 camera views. We've released video data, annotations, and our annotation tool. On the right, you can see examples from our various camera views in different locations. This work is derived from the MEVA dataset, which can be found on mevadata.org. But MEVID is more than just a person search dataset. MEVID combines tracks with unique person identifiers with MEVA activity annotations. This allows for long-term, person-specific activity recognition research. This research could support developing methods to automatically answer questions like, where did the person who left the bag in the lobby go next? On the upper right there, you can see an example of a MEVA activity annotation. It's a single frame showing annotated with a person carrying a bag, opening a door, and exiting the scene through a structure. And you can see a distribution of different activities and how their frequency in the MEVA dataset there on the lower right. Our dataset has considerable track diversity. All people in the dataset are paid actors selected to match the demographics of the U.S. population and have consented to the use of their image. We capture tracks across a large number of backgrounds, viewpoints, and outfits. Our dataset has a significantly larger variation than existing ones in terms of clothing change, where we have 2 times more changes of clothes per individual, 3 times more locations relative to other datasets, both indoor and outdoor, and we have 3 times or more wider range of target scales, that means pixel on target variations, than other datasets. You can see there the distribution of number of outfits per person, the size of the tracklets, the people in pixels, and the various different locations in our train and test sets there on the right. Change of clothing presents a significant challenge to existing ReID methods. You can see that with the same clothes, a person can be identified now with state-of-the-art methods in our dataset at about 39 MAP. However, when we introduce changes of clothing, that MAP drops to 5.7%. So this presents a significant challenge to existing ReID methods. Effectively, we know now that ReID methods struggle to find the same person in different clothes. Varying the location does have an impact on the performance of ReID methods, but to a lesser extent. And finally, scale variation of the level that MEVID also presents a challenge to existing methods. In conclusion, previous datasets have enabled us to push the state-of-the-art in video person ReID, but lack sufficient variety to emulate real-world conditions. MEVID demonstrates this failure of state-of-the-art methods and puts a new challenge out there in terms of dataset. To our knowledge, MEVID is the most varied person ReID dataset to date, and MEVID opens the door to visual question answering research that ties activities to individuals. We hope to see follow-on work in this direction based on our dataset. Please visit us at our poster if you have questions or would like more information.